In this tutorial, we'll take a look at how we create schemas in OrientDB. As before, it's a good idea for you to have the model in front of you, or you might have issues following this. Here's basically a schema shown in UML. We have two vertices, the member vertex and the article vertex, or two documents if we want to look at it from a document perspective. Both having three properties, to their strings and date in this case. We also have edges. We have the follows and replies. The follows is capturing members following other members, and articles have the concept of other articles that is used to reply to the original article. And that's pretty much our model. I'm going to start up in the OrientDB Studio and create a database. There are a couple of options here on how we store it. I was thinking of making memory, but I'm going to use the plocal so we can persist it in case something goes wrong and I can go back. Obviously, if I used memory, if I went back and restarted the server, it would be lost. Let's just call it MyDB maybe. Another option will probably be, well, anyway, MyDB is probably a bad name. How about articles? The user, here is where, if you remember in the beginning, I added a user, so I had Peter, easy to remember, as my admin password here, or database password. I'm going to switch to articles and use admin to connect. At this point, we should be back into our familiar database command window, and if I execute, you'll see that there are no vertices in this database.
You may wonder why I can query all vertices in the first place. Even an empty database has some classes in OrientDB. I'm using the correct word here, classes, when perhaps this may be a bit confusing for someone with a relational database background. Perhaps it would be better for me to use the word table. The point is, even an empty OrientDB database has some predefined types. One of these types are simply named V. V, of course, stands for vertex. We can study the schema of the empty database by clicking on the schema option. I'm not going to explain the schema here, but this is the place where we would define our schema. So without further ado, let me start on that task.
We have the option to create a new class. I'm going to create a class called member and make it a subtype of V, or a vertex. Okay, there is an abstract option here, but obviously our members are not abstract. We can create instances of it. So here it shows me that I've created that member, and if I click on that, I can actually now start adding properties. So we had the concept of a name. It was of type string. We had that's probably mandatory, not null, maybe a minimum of 3 characters. I'll save that property. It prompts me to log back into the database here. I don't know exactly why it's doing that, but I've noticed it does that in the first time I go into a database. Anyway, create another property. The next property will probably be, what was it? We needed a password. Also type string. I'm not going to make that mandatory or anything. I'm just going to save that. And then we had also email, so we'll add that property. So this is the wizard approach. It's quite convenient. It's quite easy to use, and it's a nice way of creating a schema, particularly in the beginning, before you get familiar with the database. I'll show you a different way of creating schema later, but before we do, let's go back to the command window and make sure that the member works. If we now select start from member, that should be a valid query. Of course, there's no records found. We could insert one really quick to make sure that that everything works. So we could say insert into member and set the values. We had set the name equals Peter in this case, and password, could set it to secret maybe, And finally, we also need the email. I will use my real email address here, although I need to quote it. So, oh boy, what happened there? Anyway, petter.graff@scipike.com, and execute that, and we should see a new object being created. And we see that at the bottom, and I should now be able to go back and select start from member, and we should see my name or that user show up. So that was creating a simple class, inserting an object. We can also do a select start from V now, but since V is the superclass of member, that should also work. It should give us the same result. Okay, I'll show you a different way that we could create schema fragments or schema. Another way would be to use the command window. We could do create class, give the class a name here, article, and say it extends V. Okay, so that would be creating the class, and we should see that class. We can now create properties also. I'll create a property and call it article.title, and that was a string type, so we should be able to execute that. Oops, what did I do here? Oh, I misspelled property, didn't I? So at least the parser is working correctly. So let's fix that. We'll use 1p in property and then execute, and we'll see that this now added the property title to the article. We'll create the content also and execute that, and we also had when published, which is a date. So that should be fairly straightforward. We can now go into the schema and take a look at the schema using the wizard also to see if everything works. But before I do that, let me alter the title and set, say, the min to 3. So you can see you can also insert the constraint through the command window. If I go into the schema, there is some weird bug here which forces me to go into the schema twice to see the newly created article class. I don't know exactly why that is. It's probably something might be fixed in a later release. Anyway, I'm going to go back to the schema, and now you can see that the article exists in here. And we can see the 3 properties that we created now through the command line. And I can modify the constraint. That might be a little easier to do here. Might be the title is both mandatory and cannot be null. So that would be a simple way of doing it. Simply save the changes that I've done, and we've now created schemas in 2 different ways, through the wizard and through the command line. Next, we need to create the edge types. Edges are also classes, so I'm going to create a class follows and simply extend E for edge. Pretty simple. And then create another one which was replies, which also extends the edge. Now it's interesting here to take a note of the fact that although the edges are typed, there are really no constraints on what kind of types they're connecting to. Anyway, here we see the same error where I need to refresh the page. So it doesn't show me the follows and replies before I go back to the browse and back to the schema, and when I do, I should see it, and we can see now that they're at the bottom. So those are the 2 edge types that I've created. Anyway, they do not constrain where they're going from and to, or what kind of classes they go from and to. And here it might be worth to go back to our model and take a look at it. So we had no problems creating the vertices, nor any problems creating the edges. But it is worth noting that there are a few things that may be lost in the transition from the UML model over to the graph. The follows is an edge that are not constrained to go to from member to member. In fact, it would be possible to say a member follows an article or an article follows another article. This has some strengths and weaknesses. Also, if you look at the article edge, it goes from article to article with the same type constraint that has been lost, but also the fact that it can only follow or be a reply to a single article is also a constraint that is lost in the transition to Graff. But this is relatively easy to fix, and there are something called triggers that allows you to implement these constraints or put those constraints back into the graph.
A couple of other things that are worth noting here is that the member and article was actually made subclasses of V for vertex, and the replies and follows links were made subclasses of E for edge. If you're a Java programmer, you might think of it as V being the concept of object, if you want, and E wouldn't have any comparable feature in Java. But you may also be thrown by the fact that I created a class for the edge whose name is all lowercase. This is just a naming convention. And of course, if you're a Java programmer and this is a little disturbing to you, you could always use a capital F for the relationship. But it's fairly common here to use the lowercase for lower camel case for the associations, and use a first letter capitalized camel case for the types.
That pretty much concludes this tutorial. As usual, please leave comments so we can improve these videos in the future, and thank you very much for watching.